Dear students, in the class we are going to discuss the multiple integral introduction. See, already we have studied in our lower classes about the definite integral. What is the definite integral here? Definite integral means when a function f of x, that is in generally we can write that y equal to f of x, we can write. So y equal to f of x. The function f of x integrated with respect to x between the limits a and b. So generally how can we draw that a and b function f of x is it is a x-axis, it is x-axis, it is y-axis, some function is there, it is some function f of x, then limits we can take x equal to a and x equal to b. If we want to find that area in between this region, then we have to use the definite integral over a to b f of x dx. Generally we can denote that as I. That we can concept that the single variable into two variable, that is f of x is into f of x comma y. So if we want to integrate that f of x comma y in the region y0 to y1, x0 to x1, f of x comma y dx dy, generally this is also can be written as integral I. Okay, so if the integrand is a function f of x comma y, and if it is integrated with respect to x and y repeatedly between the limits x0 and x1, that means what is the limit of this x here? X0 less than or equal to x less than or equal to x1, and then y0 less than or equal to y less than or equal to y1. These are the limits. So we can get the double integral is denoted by the symbol I, that is equal to integral over y0 to y1, x0 to x1, f of x comma y dx dy. So here we can see that x0 and x1 is there. That is called the limits of inner integration limits. This y0 y1 is there, that is outer integration limits, and then here dx is that inner integration variable, that x is that inner integration variable or inner integral, the dy is there, that is outer integral variable. First we have to integrate with respect to x. Temporarily we can keep it that y as a constant. So for that inner integration, x naught limits that x naught and x1 may be that function of y are constants. That x naught and xy, here we can write the note as x naught and x1 are the function of y are constants. But the outer integration limits are there, y0 and y1. This y0 and y1 should be that constant. Should be the constant. It should not be that function of x. So always inner integration limits may be that variable or constant. Outer integration limit should be that constant. This is the double integral. Extending the concept of the double integral to triple integral, then we can get that the triple integral as, it is also denoted by I, f of xyz dx dy dz. So here x is the innermost integration, y is the middle integration, z is the outer integration. So here also, how can we write that limits for x, y and z? So here x limits are x0 less than or equal to x less than or equal to x1, y0 less than or equal to y less than or equal to y1, comma z0 less than or equal to z less than or equal to z1. So how to evaluate that double and triple integral? Even if you are writing the triple integral here, I equal to, how can we write the triple integral here? I equal to triple integral over f of xyz dx dy dz. So it is the innermost integration, it is the middle integration, it is the outermost integration. Is it not? So here we can write this as x0 and x1. That x0 and x1 are the limits of x. This may be the constant or functions of y and z. Okay. Then here middle integration limits are y0, y1, that y0, y1 may be the constants or function of z alone. It should not contain any x and y. Okay. Similarly, z0 and z1 are should be only the constant. It not contain any variable. Any variables. So always keep it in mind, the inner integrable may be that constant or variable, but always outermost integral should be that constants. It should not contain any variables. Okay, next we are going to see how to evaluate that double and triple integral. Okay, so generally the double integral is expressed as I equal to y0 y1, as we see just now, f of x comma y dx dy. So to evaluate the double integral, first we integrate with respect to x here. With respect to x, partially y as a constant, then we integrate with respect to y between the limits y0 and y1. What is the general parts, general skeleton of the double integral? What are the parts of the double integral? So here the first bracket is there and it is denoted by I equal to y0 to y1, x0 to x1, f of x comma y dx dy. Okay, so here that x0 x1 f of x comma y dx, that is the inner integral, and then y0 y1 dy is that is the outer integral. That x0 and x1 are the inner integral limits and y0 y1 are the outer integral limits. Okay, fine. Sometimes Some additional things are there here. In case in the double integral, how can we denote that? I equal to y0 to y1 and then x0 to x1 f of x comma y dx dy, isn't it? So in case all the limits are constants, x0, x1 and y0, y1 are constant, simply we can write as x0, x1, y0, y1 f of x comma y dy dx. It is possible only when the limits are constants. In case if it is the limits are variables, inner integration limits are variables, we are not able to change the order. Okay, so this is possible only when it is possible only when x and y limits are constants. Okay, next we are going to see how to evaluate that the double integral in case the limits are constants and variables. So here see one note. Since the resulting function got after evaluating the inner integral is to be a function of y, the limits x0 and x1 may be the either constant or function of y. Sometimes y0, y1, x0, x1 f of x comma y dx dy is also denoted as y0, y1 dy x0, x1 f of x comma y dx. So here we can write the dy separately here. Then we can first we have to integrate with respect to x, then we can integrate with respect to y. So what is the region of integration? How to identify the region of integration? Case 1. What is the first case here? All the limits are constants. All the limits are constants. All the limits are constants means x and the limits of x and y are constants. The limits of x and y are constants. Okay. So what is the region of integration here? The region of integration is x lies between that a and b, and then y lies between that c and d, where a, b, c, d are the constants. Then how can we draw the region for this? How can we draw the region for this? First it is a x-axis and y-axis, and then we have to draw the straight line x equal to a and x equal to b, y equal to c, y equal to d. See the 4 points are there, a, b, c and d here. So what is the region of integration? A, b, c, d is the region of integration. Is the region of integration. So what is our first work from the given double integral? From the given double integral, first you have to draw the rough sketch for this. First you have to draw the rough sketch for this. It is a rough diagram for the given integration. Okay, this point is 4. Then how to find that intersection points of the line? Generally, how can we write that the Cartesian coordinate? The Cartesian coordinate can be written as x comma y. So first always x value, y second is that y value. Okay, so here we can see that the straight line, two straight lines are there. It is intersection of point A is intersection of x equal to A, y equal to C. Is the intersection of point A is the intersection of x equal to A and y equal to C. Therefore, directly we can write that it is a constant na, x equal to A, y equal to C. Therefore, A becomes A comma C. Similarly, we can write that the point P. Point P is the intersection of x equal to B and y equal to C. Therefore, x equal to B you have to write first, y equal to C second. Okay. So similarly, we can write that the points C and D. After identifying the intersection point of the region, we have to draw that the region, that is we can identify the region of the integration. So it is a region of integration. It is a region of integration. What is the next work? Next work is you have to identify what is the inner integration variable. What is the inner integration variable? So here what is the inner integration variable? We can change the color for this. What better? Not green. Green is better. Okay. So you can take the green. Here what is the inner integration variable? X is the inner integration variable. Our first work is you have to draw the parallel line to that inner integration variable axis. Draw the parallel line to that inner integration variable axis. So what is step 1? Step 1 is draw the parallel line to inner integration variable axis. Inner integration variable axis. Okay. So if you draw the parallel line to inner integration variable axis, what is the inner integral variable axis here? X. So we can draw the parallel line here, some stripe. See here in the region, it is starting from x equal to A here. In case if you are writing the starting is P here and the stripe is Q here, then stripe PQ. You can consider the stripe PQ. In the stripe PQ, starting from x equal to A and then ending with x equal to B. See that x equal to A and x equal to B. You have to see in the region. Okay. Next one is to write the outer integral variable. To write the outer integral limits. To write the outer integral limits, that is, what are the limits here? C and D. To write the outer integral limits, first you have to take that the region values in the axis. No need to see in the region. No need to see in the region. I can say the two methods are there to write that outer integration limits. First one is see in that what are the values of y value in the axis. So here outer integral variable is y. So what is the y value here in the region? C and D. Otherwise, you can do one thing. In the intersection points are there now. In the intersection points, outer integral variable, intersection points are C. Okay, this is a different color. We can change it. It's not visible actually. So we can change that C. Okay. So it is C and then it is D. Okay, so easily you can identify in the region what is the values of y. That is, you have to look that what is the value, what are the values of y in the region. That is, you forget about x because already we have written that the limits of x here. We have to write only that values of y because as I told that x limits, inner integration limits may be the constant or variable. That's why you have to see in the region. But for the outer integration variable, there is no confusion. That is, you have to see only that the intersection points in the region. What are the intersection points in the region? Either you can take here or end of the region or starting of the region. Anywhere the y values will not change. Okay. So C and D you can verify here. Here also the values of y is C and D. Here also the values are C and D. Is it not? Here also we can see that the outer integration variables are C and D. Is it not? So therefore, this pen also we can change it to that yellow is somewhat better for us. So therefore, here we have to write that inner integration limits from the region. Once again, I repeat how to write that inner integration limits from the region. To write the outer integration limits, no need to see in the region, either see in the axis or in the intersection points. Okay, this is a shortcut to write that the limits of the integration. As I told, if the limits of the integration are constant, you can easily interchange the limits of, order also. Dx in terms of, so first you can integrate with respect to y, then you can integrate with respect to x. Similarly, that means here you can see r xi equal to integral over first, here what is the inner integration? Inner integration is x. If you are changing the order, the inner integration is y now. If all the limits are constant, if you are changing the order, the values are not changed. The values are not changed. Only the order is changed. See here note, if all the limits are constant, simply we can change the order of integral. Okay, here I want to mention one thing, that is to identify inner integration limits, you draw that one line in the region, one parallel line in the region. To write that outer integral limit, to write the outer, what is the outer integral limit here? Y. You have to draw the parallel line to that y axis, two straight lines. So easily you can identify which one is the inner integration, which one is the outer integration. So what is the inner integration? Inner integration is the single line, outer integration is that double line. Easily you can identify for the differentiate of this. Differentiate that inner integral and outer integral. Okay. So we can see one simple example based on this. Write the problem. That is, we can view that this ruler. Okay, it's not easy to write. We can extend it. So what is the question here? For example, verify that integral over 1 to 2, integral over 0 to 1 x square plus y square dx dy equal to double integral over 0 to 1 and then 1 to 2 x square plus y square dy dx. So from this question, what we are going to try to understand is, that is, even if you are changing the limits, changing the order, that values of the integration is not changing the value. Only you have to change that the limits. Okay, that is, here we are going to show that, write the solution for this. As I told that, first you have to draw the a rough diagram for this. For any problem, First you have to draw the rough diagram. Rough sketch or rough diagram. How to draw the rough diagram? You can take the axis now, some shapes. Here, these are the constant we can take as a square or rectangle, that we can take the shape here, square or rectangle, 0 to 1, 1 to 2. So what is the 0 to 1 here with respect to x? 0 to 1, and then y is 1 to 2. Okay, you can draw here x equal to 0 to 1, and then y equal to 1 to 2. Is it that? Then we can move here some to some height. Okay, fine. In case it is O, and then this point is A, this point is B, this point is C, this point is D. Then what is the inner integration variable here? X. For that x, we have to draw the parallel line to x-axis as we told. So draw the parallel straight for that x-axis. Draw the parallel line to x-axis here. What is the lower limit here? X equal to 0. This is y-axis is x equal to 0, and then x equal to 1. Okay, y equal to 1 to 2. Approximately I am drawing. Okay, so it is y equal to 1, and then y equal to 2. Not exact diagram, just some approximate diagram. This is the region of integration. Region of integration. So this is x equal to 1, and then y equal to 1 to y equal to 2. So how to integrate this? I equal to, first you have to take that left hand side, then we can integrate right hand side. I equal to integral over 1 to 2, integral over 0 to 1, x square plus y square dx dy. So that is equal to, first we have to integrate with respect to x. Temporarily we can keep it that y as a constant. That is integral over 1 to 2, then x cube by 3, because we are integrating with respect to x, mean integration of x square is x cube by 3 plus y square is constant, keep it that y square x. Then write dy here. What are the limits? 0 to 1. So therefore integral over 1 to 2. So we can write that note here. When you are integrate with respect to x, y is constant. Y is constant temporarily. So 1 to 2. First we have to substitute the value of 1 here, then lower limit 0, leave it. So 1 by 3 plus y square dy. Then you have to integrate with respect to, first you have to integrate with respect to x, then you have to integrate with respect to y now. So when you are integrating with respect to y, what you get? Y by 3 plus y cube by 3 from 1 to 2. First you have to substitute that upper limit. 2 means 2 by 3 plus 8 by 3 minus 1 by 3 plus 1 by 3. So if you are simplifying this, you will get 8 by 3. That is the answer. It is for the left hand side value. Similarly, we have to take the right hand side value. What is the right hand side? Right hand side is, if you are changing the order, See that 0 to 1, 1 to 2, x square plus y square dy dx. Right here, integral over 0 to 1, after changing the order, you will get 0 to 1, 1 to 2, x square plus y square dy dx. So first you are integrate with respect to y, treating x as constant, treating x as constant. Then what you get? X square y plus y cube by 3. What is the limit here? Y equal to 1 to 2. Dx is outer integral. What is the limits of the outer integral? 0 to 1. Substituting that value here, you will get that 0 to 1 x square. First you have to substituting that value 2 here and then 1 here. That means 2x square 2x square plus 8 by 3 minus x square plus 1 by 3 dx. What do you get? 0 to 1. 2x square minus x square is x square plus 8 by 3 minus 1 by 3 is 7 by 3 dx. Now integrate with respect to x. What do you get? X cube by 3 plus 7x by 3 from 0 to 1. So substituting that value of 1 here, no need to substitute 0 because it will be 0. So 1 by 3 plus 7 by 3, which is equal to 8 by 3. This is the RHS value. Therefore, herewith we verify what is the LHS value? 8 by 3, and then RHS value also 8 by 3. Therefore, here we verified, hence verified that the two double integral are equal. The two double integral are equal. Okay, this is a very simple example. So from the above problem, what we are noticing here, if the limits of the integration in double integral are constant, then the order of integration is immaterial. So provided the relevant limits are taken for the constant variable. That means if you are changing the limits, if you are changing the order, that is you have to change the limits accordingly. That's all. When if the limits are constant, if the limits are variable, that is not possible at all. Okay. So thank you. It is very simple example for the double integral. So just we can recap that what we have discussed in the class for the double integral or multiple integral introduction. For any given problem, first you have to draw the a rough sketch for this. From the rough sketch, then you have to identify the region. Then we can integrate first for the inner integration variable. Then we can integrate for the outer integral variable. And one more very important thing in the rough sketch, you have to draw the parallel line to the inner integration variable axis. And one more thing, to write that inner integration limits, you have to see in the region. To write that the limits for the outer integration, no need to see in the region, just you can see in the either in the axis or in the intersection points in the region. Okay, in the next class we will see many things elaborate. Thank you so much.